go on. So, hello everyone. Here are Con, Soft Alpha, Aeon, Lucas. Thanks for coming. As you know already, this is an Ask Me Anything session with Teddy. Teddy is an expert from the product team in the Stanley Foundation in AI, in privacy, but you can also ask him about Bitcoin or other projects that you may have in mind. So, I mean, every hour of Teddy's time is very expensive. So now is your time to ask him for free for you. So let's use that time properly. And if someone wants to start asking, go on. Otherwise, I will go on with the questions I have here coming from Dora Hacks participants. So yeah, Lucas, Aeon, Soft Alpha, Arco, go ahead if you want already. Otherwise, I will go with the question from Dora Hacks. Let me open.
All right, I'll read out the question.
Let me. Oh, perfect.
In the chat.
All right.
So you can ask in the chat. Feel free to ask in the chat, and I'll get to them as we go. So Arco is building a privacy layer on Starknet, where users call any contract from shielded Bitcoin balances via a decentralized relay network. The user experience feels like a normal wallet. Nice. A single Merkle tree holds the balances and contract types. Also nice. And users generate graphic scene proofs locally. Relay submits to a shielded pool. Garaga verifies, and the pool forwards a call. Target contracts only see shielded pool called swap. Never the user. Nice. A unified pool gives a larger anonymity set than tornado-style isolated pools. Yep. But timing analysis could link deposit to actions. True. Is a unified pool still the right design, or do isolated pools reduce linkability? I think the classic example of anonymity sets are like glasses of water, and the more drops of water you have in that glass, the better it is. I think timing attacks are generally a concern, and there's a lot to be desired on the tooling side of things to help facilitate users to have anonymity by not having traceable or repeatable actions. So if you can allow a user to have recommendations on when to do things, how often to do things, to help facilitate some sort of a privacy maxing ability, I think that's really valuable. So I think the standalone single pool is just as good as usual. The real feature that you want to build to help facilitate better privacy practices is that sort of privacy maxing toolkit that helps users better utilize the anonymity set that you've got. So I'll give you one simple example. On Starknet, you can DCA between two ERC20s, for example. So if you want to DCA from USDC into Stark, you can do that through an automated process, and you can constrain an entity to do that for you, right? A more interesting design pattern that's relevant to why that doesn't work in typical anonymity protocols is because the process is repeatable. I know that I would usually DCA $1 every hour, for example. But if you can DCA random amounts per some standard deviation, for example, you start to look less similar than you usually would. And so I think there's a bunch of really interesting tooling to build in that direction. So I think that's one interesting area to build in. Does that make any sense? So single pool is good. Well, just make sure that you have good tooling to help facilitate that anonymization.
Arco, if you want to ask further, okay, Arco says that thank you very much. But Arco, I mean, we are not that many people here, so if you want to ask further, feel free to ask further. Okay. All right. So Soft Alpha, thank you very much, Teddy. Soft Alpha, if you have any questions, please either unmute yourself or do it here in the chats as you prefer. The same for the other guys here, Lucas, Aeon, Carla, Sergio. Feel free to ask Teddy here. As I was mentioning, ask him anything you want, privacy-wise, Bitcoin-wise, protocol-wise, whatever you want. Here's Teddy can we can borrow his brain. In the meantime, I will ask one of the questions coming from the Rahabs. So one of the questions is on the privacy track. So Teddy, you before mentioned about implementing semaphore on a Starknet. So basically porting the semaphore protocol to Cairo for anonymous group membership and sign a link. What do you think is the power in this, and how would you implement this? Importing semaphore to Starknet.
Can I share my screen? I was just looking at this
yes.
before the call. Hang on. Chrome tab. This one. Okay. Can you guys see the screen?
Yes. Beyond the normal game,
you can see the.
Yes.
You can see, yeah,
the
cool.
slide.
So yeah. So I like semaphore for numerous reasons, mostly because you can get these anonymous groups, right? And it's not immediately obvious why that's valuable, and you can do a bunch of things with semaphore, right? But I think it really becomes interesting when you say, hey, we can use privacy tooling on quality applications to add a new dimension to what they do. Loot Survivor 2 is a game on Starknet. It's a roguelike play to die, if you will, game. And I think semaphore adds a lot of value to it because it allows you to facilitate these quest masters. These quest masters can be good or evil. Loot Survivor 2 also has a quest protocol, so I can mint Omar a quest and say, Omar, if you get to level 15, I will give you a sword. And so there's ways of facilitating interactions already. I can already be a quest master to Omar. Omar can be a quest master to me and many other people, right? But what if we wanted to add more lore to it? And I think this is where semaphore comes in, because what we can do is we can have anonymous groups of quest masters, and those quest masters can be good or evil, right? So much like you might have Jedi and Sith in Star Wars, or Sauron, for example, in Lord of the Rings. We can add a relevant dimension. We can do that with semaphore and onometers. So if you played Red Dead Redemption 2, you'll be familiar with onometers as well, right? So how does this work? In general, we can have a group of quest masters, and those quest masters can form an anonymous group using semaphore. And what they can do is they can interact with the quest generation protocol, and they can say, hey, I am a quest master, but you don't know who I am, and therefore you don't know if I'm good or evil. I've minted Omar, I've minted Teddy, I've minted Fran, Parsley, or Cassio. A quest. The quest is complete level up to level 20, and you get some loot. But the risk here is that you're risking your onometer. So everybody has some onometer. You're in comparison to others, you might be less evil or more evil, right? Depending on how your journey has gone so far through time. And what can happen is if these anonymous quest masters can mint you a quest and you risk your onometer, is upon completing the quest or upon failing the quest, you can become more good and more evil. This is really fun because it creates factions amongst the community. It creates additional lore, so you can imagine all sorts of fun things that can come from creating these factions. Quest masters can try and attempt to make players become increasingly evil, more Sith, for example, right? And so you can build up, your community, your clan, just by being a more interesting and proactive quest master. I think this is what things like semaphore are really valuable for, right? They allow us to add a new dimension to existing gameplays to allow people to alter between good and evil in this case. There's a bunch of other ways you can do it, but the same thing can be used for proving that you stake both Stark and ETH. In all honesty, that's kind of a boring thing to do in comparison to anonymous quest masters and allowing people to become part of different factions within a gaming ecosystem. So I think there's a lot of fun to be had. Privacy is really fun when you get into it. It just takes some time to cross that barrier from saying, like, okay, I can apply it to these sorts of scenarios.
All right. Okay. And for that, we need to port it to Cairo, right?
You just need a verifier. You just need a verifier for it in Cairo.
All right, all right, all right. So okay, perfect. So I will. So people here, you already know that's a project that you can do, and Teddy has a big interest on that. So seems very, very interesting. All right. Thank you, Teddy. Thank you, Teddy. I will share that further in the Telegram group. And the Dora Hacks people asking. Okay, there's some question here by Lucas and Arco. If you want to go to read the Teddy by Lucas.
Which
Oh,
one? My
let
question
me
is,
also. Oh yeah, go ahead, Teddy.
my question is if there's a way to implement confidential transactions with regular ERC20 tokens on Starknet. I saw some resources in a library called Tongo that seem to do the trick. Indeed, Tongo does do the trick. It's not possible. Yeah, in the ERC20 is a standard. It's not possible to mutate that standard. You get a different protocol once you mutate it. But maybe some commentary on how Tongo works. You can think of Tongo as like an extension to an ERC20 contract, or perhaps an extension of the state, to be specific. So an ERC20 contract, you will see a map of addresses to balances. And in Tongo, you would see something similar. But instead of balances being some U256 or some number that you're familiar with, you'll see ciphertext. So you'll see a tuple, just two very big numbers that you don't know what they are. You'll know what they are when a user deposits into Tongo, because you'll be able to see that, for example, myself or Omar deposited in some amount into Tongo. So you'll be able to infer what that is. But once that balance starts changing from that, once a user starts making transactions with Tongo, much like they would with any other ERC20, it functions in a pretty similar way. You won't be able to infer what that balance is. So Tongo does do the trick. Tongo does have its contracts deployed on Sepolia and mainnet. And it works through just good ergomal encryption. So you prove the constraints of ciphertext deltas is the more technical way of saying it. Does that answer your question, Lucas? So basically you need a contract to verify constraints have been satisfied, and you need a little prover. In Tongo's case, it just relies on some good elliptic curve cryptography, some range proofs, some bit proofs, some proof of exponents, and a few other bits and pieces. But that's it. That's how it works. If you want to look up what the actual design pattern is, it's called Zether, Z-E-T-H-E-R.
Also, Lucas, if you want to take a look, the code is it was recently open source, Lucas, so you can see in the docs all the documentation and the open source code, Lucas, if it's useful for you.
Yeah, I thoroughly recommend checking out their docs, the docs.tongo.cache. They're really comprehensive and go through how the protocol works, and it's really helpful just to get a feel or understanding for some of the complexities that happen on the confidential side of things.
Amazing, 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 Teddy. Thank you very much for that. Lucas, feel free to ask further if you want. We have time, and there's a question by Arco, Teddy, if you want to go through it.
Yeah, another small question from purely a participant side, with an idea that I pitched to you just now. Should I be going more towards the DeFi side, make prediction markets a private AMM already in its current version, or should I be full on privacy protocol? What would you like to see? Totally up to you. If you want to be a purist on the prediction market side, a good prediction market should allow users to be anonymous. Why? If a prediction market can allow users to trade anonymously, it reduces herding. So I'm sure some of you might have seen a lot of the commentary on Polymarkets and all the news feeds, and for example, Polymarket Builders or the Kalshi Builders program. One of the issues with a lot of purist issues on the side of things is that people are building copy trading bots. That's not difficult to do, pretty bog standard. The issue with that, though, is that you're just copying somebody else's belief, which amplifies their signal. And in a prediction market, when you trade, you're expressing some signal as a function of the cost. And to amplify that signal is to go against it. So you're basically overpricing the signal. So what a purist prediction market should do is facilitate anonymity to better eliminate copy trading or herding towards one specific belief. That's just a good feature in general to have. You can stick on the DeFi side, you can stick on the prediction market side, you can stick to the gaming side. It doesn't really matter. One thing I would encourage you to do is make sure that the privacy features that you implement add value to the protocol it's connected to. And I think one way of doing that is answering who are you hiding from. A really terrible way that a lot of people go about answering this, particularly in the cypherpunky space, is they will say, I'm hiding from the government. Weird. But if you're playing games, for example, if Omar and I are playing poker, right? It's very easy for me to know who I'm hiding from. I'm hiding my cards from Omar, and Omar is hiding his cards from me. In a prediction market, similarly, I'm hiding who I am, so you don't know what signal I have. If you know I'm a super forecaster, you probably want to follow on and copy trade me, albeit not in the best possible way, because that introduces herding to the market. It's valuable for the market to have unexpected uncertainty. And so I would encourage you to think about answering that question of who you're hiding from in any case.
That's an amazing question. That's an amazing question, right? Like, it's a good change of mindset, right? Who are you hiding the information from, right? I never think about this. Sounds, yeah, most people is the government indeed. But
it's something that I wish people would think about more too, because it's a fundamental part of privacy. Just because you're being private doesn't mean you're actually adding any value. For example, if you were to deposit in Tonga and do nothing, you're not really getting any confidentiality. You have some encrypted state, but we can infer what it is because we know how much you've deposited and we know that you've done nothing with it. But being able to answer just good questions, who are you hiding from? I'm hiding from Omar because we're playing poker and I don't want him to see my cards. And conversely, there's another form of poker where you can see everybody else's cards, but you can't see your own. Here's another way of thinking about it. Like, I'm almost hiding for myself, if you will. It's these games of limited information, where information is valuable. It's a pretty good question to answer. So if you have a good answer to those questions, I would encourage you to go in that direction instead of not having a good answer to it and going in a different direction. Does that make sense?
Interesting. Arco. Okay,
No
Arco
problem.
says yes. Thank you very much. And there's a question by Soft Alpha. If you want to go through it, Toby.
Yeah, I'm building a proof of pay, privacy-preserving Bitcoin payment receipt system where a merchant creates an invoice on Starknet, which includes some amount, destination commitment, and some expiry. The user pays on Bitcoin, and then the user redeems the receipt on Starknet to unlock access without revealing their wallet graph to a merchant. My question is, what is the right privacy security design trade-off between A, keeping the receipt minimal, disclosing public and composable on Starknet, B, adding stronger linkability, mitigation through hiding transaction IDs, amounts via commitments, paid greater than X proofs, redeeming via relays, delays to reduce timing, correlation, signatures, trust and verifiers, and what else would you prioritize in meaningful privacy improvements? This is a long question. So Bitcoin, so a user pays on Bitcoin and the user redeems a receipt on Starknet. The one fundamental challenge here is going to be either trusting somebody or not trusting somebody. So this is where I think you'll run into some difficulties. If you want to trustably bridge from Starknet, from Bitcoin to Starknet, Starknet needs to know about Bitcoin state. It needs to know that you've done something on Bitcoin. So if you're able to prove the current Bitcoin state, then as far as I know, Omar, correct me if I'm wrong, you can prove the Bitcoin headers in a repo, I forget the name of, but it's in a Keep Starknet Strange org. What you'd like to do is prove the Bitcoin state. And if you can prove the Bitcoin state and post it on Starknet and it's verified, what you can do is withdraw some amount from that. Else you'll need a facilitator. But yeah, I think that's where you'll find issues. Generally, bridging is going to be trusted if both chains don't know about each other or one doesn't know about the other. So that's where you run into some challenges. Does that make sense, Alpha? Else, when the other parts of your question on reducing linkability, you really want to benefit from stealth addresses. You really want to benefit from encrypted amounts, allowing users to prove that they own a stealth address, allowing users to prove how much an encrypted amount is. So there's a lot of constraints to consider, particularly when bridging on both security and trust or trustlessness.
Teddy, were you talking about Raito from Keep Strong and Strange?
Do I want to what?
Sorry, were you talking about Raito before?
Might have been. I think it was a while ago. But as far as I remember, it does prove the Bitcoin headers.
Yes,
From
yes, I
memory.
think
Or the hash of Bitcoin headers, something like that.
indeed. I think that's the point. Yeah, applications. Yeah. All right.
My other
yeah.
point, maybe soft alpha, is that the privacy application need not be incredibly complex. You can get a lot of value out of something very simple. Something like the incremental Merkle tree that something like Tornado Cash or other mixers do is incredibly valuable, particularly if you can link it to something that helps facilitate the interaction.
Amazing, perfect. All right. Feel free, please, soft alpha, to ask further if you want. All right. And there's a question by Lucas. Penny, if you want to go through it.
Yeah. To give a bit more context on Lucas's idea, to implement a sealed bid auction. But the thing is, even if we make the main contract private, an attacker who knows the contract address could figure out who participated by searching the IC20 tokens made to the contract. That's correct. So to make it 100% private, we should make the transfers confidential. And this is where Tomo comes into play. Sounds like a promising product. I think so. This is from memory. I'm trying to remember what Lucas's original question was. Was about Tonga. Okay, yeah. It's definitely valuable. But I think the point about 100% private is an important one to clarify. When we're dealing with privacy protocols, there is a time before privacy, there is a time while you have privacy, and there's a time after. And the period of time that you have privacy for isn't guaranteed. Because just because you're in, for example, a protocol like Tonga, if you're doing repeatable actions and you're not privacy maxing, so to speak, you can be tracked. You're leaking information through that repeatable process. So I think this is one of my points earlier to Arco. What you really want to do is help facilitate users do privacy maxing behavior. If you can have recommendations on, hey, your last transaction was 20 minutes ago, maybe wait another hour and a half. Or the delta between your last two transactions was 5 minutes. Perhaps consider waiting or doing one now. I think the more we can facilitate that, the longer that period of having the user has privacy for, the better. Else, users start leaking information. They move from being private to being somewhat known, or at least people can infer what they're doing. It's much easier to plan for what that should look like. I know I'm talking about this abstractly, but if you can understand the specific who you're hiding from and what they might be capable of, the better you can answer or design the tools and systems you need to help facilitate users be privacy maxing. Did that somewhat answer your question, Lucas? The sealed bid auctions are generally interesting. God forbid, somebody who is auctioning off an NFT knows that they can get a good amount of money for the NFT because they see that a whale is deposited into the sealed bid auction process. So they might hold out for a better price.
Amazing. Thank you, Teddy. And Carlos asking if someone's building state addresses. I built some state addresses that are going to come soon as a snip. I can share the code with you, Carla. Would be interesting for example, Carla. This is very, very new. But if you manage to use this stuff and maybe make it like a smart wallet with using state addresses, could be interesting. Like a state addresses wallet is like a natural next step for an implementation. I can share it with you, Carla. Let me share the repo here right now. And yes, so Teddy, some last comments, some last words before we finish the call.
Don't get sucked into complexity. It's really easy to wish the world was completely private. Some things aren't possible. A lot of things aren't possible. And I would really encourage people to go towards a more familiar design space that to them. Gaming is a really, really good one in general for it, because we're all familiar with games, and games often have hidden information, whether we realize it or not. Card games are a really good example of that. So I would encourage you to keep privacy protocols simple, and enjoy thinking about areas that require privacy, that demand it. And don't be surprised if all of a sudden the privacy feature that you're implementing sort of melts away behind the interface and isn't obviously valuable. That's sort of that should be a common occurrence. Users need not care about whether they flick some switch on or off to have privacy. It should be baked into what they're doing. They should have similar user experiences to what they do. And to achieve that, you need simplicity and not complexity.
Simplicity, no complexity. Love it. And also remember the other comment by Teddy that always ask yourself, who are you getting information from? I think that's also very valuable. Okay. Thank you very much, Teddy. Please, people that came here, feel free to DM me or write in the Telegram group that we have, and we can go on with the conversation. Thank you, Teddy. Have a good day.
Anytime.
Have a good day,
Thanks
everyone.
so much. Cheers, guys. See you later.
Cheers.